In most videos that I've done before on GANs, I showed you how to train NVIDIA StyleGAN2 ADA on fairly high-end GPUs. In this video, we're going to look at how you might do that on a more entry-level GPU. Here I have a Alienware R12, which is a computer I'm getting for my dad, actually for Father's Day. So I'm trying it out with some deep learning tasks. It has 16 gigabytes of RAM, and it has an NVIDIA GeForce RTX 3060 Ti. Now the Alienware R12, you can get it with very high-end GPUs and RAM configurations, but this is just around a $2,000 US machine with everything included. And it's decent for deep learning, but let's try to jump into GANs. The memory is the main limiting factor. I find that this GPU actually has quite a few CUDA cores, as you can see from the specs. About maybe less than half of what you would see on a high-end GPU, like I've used on some of the videos here in the past, but still a pretty decently fast GPU for some of these tasks. Let's look at what I'm doing here with training. So here you can see I have been training for approximately 15 and a half hours. During that time, it has gotten through 1,200 K images. That's kila images, so 1,000 images. Usually you want to get that up to about 3,000 K images to get at least a baseline GAN trained. I'm also snapshotting at every 50 ticks. You'll want to set that tick number so that it's reasonable. It has nothing to do with the quality. You can set the snapshot every how many ticks you want, but realize your computer is going to be tied up in between. Because if I were to interrupt this and then retrain it later, everything since the last snapshot, which was right here, is going to be lost. So if you want to interrupt this computer, especially with this fairly small GPU, I find just running video editing software will cause StyleGAN to crash. So this needs to be pretty dedicated to what you're training on something like a 3060 Ti, which just has 8 gigabytes of GPU memory. Now it's really nice that StyleGAN does show you how much GPU memory it's using. It does tend to burst both CPU memory and GPU memory at the beginning, so that is certainly one of two factors that I had to take into account when I set this computer up to train for StyleGAN2 ADA. So let's talk about the two things that I did to get this working. So first, let's talk about just performance. If I bring up the task manager, you can see as this is running, the CPU is really not doing a whole lot. I'm using maybe 1/5 of the total CPU on this. This is very common of GPU-based tasks. I know on my computer that I normally run these on, which has 48 cores, I am rarely using all of those for the entire training. Now let's look at the two changes that I had to put in to really make this work. Out of the box, this will fail. The first error that you'll see right out of the box is this one. I saw OS error. The paging file is too small for this operation to complete. Normally, I don't like to use paging files. I throw RAM at my computers. But if you've only got 16 gigabytes of RAM and your GPU has 8 gigabytes of RAM, often you're staging things to go into that GPU. So you're using an entire 8 gigabytes of system RAM just to go into the GPU. Normally, I like to have about 3 times to 4 times the amount of system RAM that I do GPU RAM. But on this computer, that's simply not an option. So what you do is a paging file. Windows does not set up the paging file that advanced when you first get the computer, because if it was properly handling it, you wouldn't get this error. It would have auto-sized. So let's take a look at this. Do Advanced System Settings. and you'll be right here. You'll want to go into performance and then go to the virtual memory. You can see I've set the virtual memory already up to about 32 gigabytes of RAM. Now realize this is going to take a chunk of your hard drive, but that's just the way it goes. So Windows will normally have automatically manage paging size. Windows does a horrible job of auto-managing that. I think Windows assumes that in this era, you don't really use paging files, you use mostly system RAM. I don't find that using paging files really hurts the performance too much on this because it's mostly staging it at the very beginning that you're going to run into this. But change this so that you're getting you'll want to change it to a custom size and you'll put in the amount. So I put in a custom size up here from 8192 to 32768. Now that assumes you have 32 gig of free space on your hard drive, or this won't work. So do that and you're going to get past that error. The other thing that you're going to want to change is, these are just some notes that I have, but this one is the most important. This is what I was actually running it with. So I'm running the train for StyleGAN2 ADA, and we'll show you how to set this completely up in a moment here. I'm just kind of giving you the high view of what you need to deal with. This is the output directory, and I'm training it on fish images. I changed the metric. We'll look at this in a moment when I start it up. Basically, I determined that it was crashing in the middle of the metrics. And I'll show you how I diagnose that here in just a moment. And then you also want to do snap. I have it actually running there on 50, but when I was first experimenting with this, I was doing 3, just because I wanted to see that it could go through 3 ticks and actually properly save before we go to, I don't want to go 5 hours or however long it's going to take to get through 50 ticks just to have it crash. I want to fail fast and fix things. Just to show you this, like I said, I'm really pretty happy with how this GPU is handling at least a 256 by 256. You can see the output here. That log.txt is what I was just showing you in the console. But the fakes, as you keep training, it'll show you the fakes at each of the K images. So at 1200, which is where I was just at, these are the fake fish. And you can tell they're looking very fish-like. You can get them a whole lot better than this. But this is basically where you're at. And these pickle files, you can see the pickle files are pretty big, 276 megabytes for a 256 by 256. These are the files that you'll want to save. That is your discriminator and generator. You'll use the generator out of that pickle file to actually create your new images when you try to actually generate. Now, I often upload these pickle files just to Colab, because Colab is plenty good for generating images. If you're using any of my Colab image generator code, you'll just swap this pickle file in, and that's what you would make use of. Training is more intense. Training is a bit annoying on Colab, but I do have a video on how to train on Colab. Also, if you're curious how much power this is consuming, you can see here it's over 300 watts, around 320, 314 as it changes through this. This is actually using more watts. I always like to do a quick benchmark where I try to mine a bit of Ethereum, and this is considerably more demanding than crypto mining. So you'll hear your computer fan running full blast and other things going on while you're trying to generate these GANs. So if you just put those 2 changes in that I told you about, you should be able to train on this low of a GPU memory. Now let's quickly go through how to actually set this up. Now, I won't be able to actually completely run this with the screen record going, because this 3060 GPU with its limited RAM, I can tell already here I have killed the training that I had going for most of the night. So let's start over and I'll show you real quick how to get this up and running. So I'm going to bring up the Anaconda prompt and I'm going to do conda create name StyleGAN Python, and that does need to be minus name. Python equals 3.8. And this will create a new Python environment that I can install the needed packages into. I'll say yes. Okay, we're in that environment. I now need to install PyTorch. PyTorch makes this so incredibly easily. I want the stable for Windows using conda Python, and I want CUDA 11. This is an Ampere GPU, so make sure you pick 11 if you have a 30 series. Otherwise, you're going to have a real slow startup time. Then we copy this line here, and we install it. I'll go ahead and fast forward through this. PyTorch is installed. So now let's go to the actual StyleGAN2 ADA instructions. So I've already started following what they said to do, just sort of from memory. This part is very important. Do not skip this step or you'll get some warnings at the beginning of StyleGAN2 where they tell you they're going to revert to the slower kernel versions. First of all, that would probably be painfully slow if they did do that, but it doesn't work anyway. It'll just crash. So the warnings are actually errors. But install Visual Studio Community Edition. Make sure you choose to use C++, which is not installed by default, and then go to this directory and run this batch file. I'm not going to show you this part because I already have it installed on this computer, but I do have a video where I show you completely how to install StyleGAN2 ADA. Just follow with that video. The link is in the description, and that should work just fine. Once you're done with that, then you do the extra steps that are necessary for a low RAM GPU. Like here, I have all of my fish images. I need to convert that into a training set, and that comes in here. And doing that is really just running the dataset tool. So the first thing to do is convert those images like I showed you there, but you want to convert them into a training set, and you use the dataset tool to do that. So if you just run Python dataset tool.py, I'm doing that first just so I can see what packages it's missing. Okay, I need click, so you just do pip install click. Now let's try to run it again. No tqdm, so pip install tqdm. And then we try to run it again. Now it's ready to run, but I need to put source, so you do -- source. You would do this, your image directory. Now if you run this, it's going to complain it wants a destination, so you've got to put the -- dest. And then you put in wherever you want really, but I'm training right to here. So it would be this. I'm not going to actually run this command because I already have these converted, and it does take maybe 5 minutes. So run that. And again, this is all in much more detail in my Windows tutorial of how to run StyleGAN2 ADA PyTorch. Now we want to train. And we're going to use this to train. I'm going to leave the metrics as it is, just to show you how I think through these problems. So here, I'm going to run this. No module named request, so let's pip install requests. Running it again. It needs psutil. Psutil does have some binary dependencies, so I like to conda install that. Okay, let's try to train it again. SciPy, pip install scipy. Okay, this is what it looks like when it's starting up. I was getting that error about memory right before, so if you get a swap file error, you need to increase that swap file size, and you need to reboot to do that. I already did that off camera ahead of this, but I showed you where the window was. This is where you'll get errors if you didn't do that Visual C++. It's going to tell you, warning, these are going to be really slow, which are lies. It's going to fail anyway. But these are two custom kernels that NVIDIA created to speed performance. I might do a video on these in the future. This is a really good example of when you want to do a custom kernel in PyTorch. Notice up here, the 16s, that's your batch size. So it's auto-chosen a batch size. If I were to run this on a higher end GPU, typically that's higher. Okay, I can hear the computer spinning up its fan. I can see the watts going up. This thing is spinning up. Hopefully you can't hear the fan. I spent money on microphones to keep you from hearing my fans. Tick 1. So far so good. This is awesome. It's going to fail, but I want you to see the process that I go through, because there's a lot of questions that I see very much related to this. And I can never have access to your hardware, and I don't have time to Zoom and remote help people. Okay, we're in evaluating metrics. That's an important cue, because you want to see where you were when you blow up. This warning, named tensors are a pretty new feature of PyTorch, and they're subject to change. That's just a warning. Don't worry. I mean, I'm a TensorFlow guy. I am used to Google throwing breaking changes, and they don't even warn you like the PyTorch people do. So I actually appreciate that message. But it's more NVIDIA's problem than mine. That's an update that they may need to make in StyleGAN2 in the future if the newer versions of PyTorch break them. Now, I can hear my fan slowing down. I can see the watts going down. My heart kind of sinks when that happens because I know something has probably gone wrong. It's not blowing up with an error yet. And boom, we're dead. This is worse than a big error blowing up. This is where StyleGAN just bombs out and stops. It exits. I have seen several questions pop up in the comments on YouTube. It stops after the first tick. Now, how do you diagnose something like this? First of all, you might be tempted this user warning, and you might be Googling this user warning. The user warning is not the problem. That's just a harmless warning. How do I know that? Really by trial and error, and also the fact that it took a while after, and also just examining the code. So if you open up this training loop.py inside of StyleGAN, this is right about where the code was having this problem. A very good technique that I use when code is just bombing out like this is I will add in logging, print, here, 1, and then I'll add, like, I don't know, I would want to put here, I am done eval. I don't make those pretty. And I just see those because it gives me greater granularity of when this thing is failing. And eventually I isolate the actual command that is causing Python to just exit. I also started to use a bit of logic here. What I also did is I took this evaluating metrics and I just deleted it real quick. I thought, okay, what happens if you just don't evaluate metrics? Because really, if you think about it, StyleGAN2, that is semi-supervised training. The metrics are really, the FID, that's really just an external number that lets you know how effective your images might be being trained. It's not really used to the training process. So I tried just deleting it. I won't take you through that, but this basically then got onto tick 1. And I'm like, aha, it is the evaluating metrics. And I do know that these metrics evaluations are intense, and they can often cause you to fail. So what I did was then started affecting the metrics. So if I copy this one, and I just do metrics A, that's going to fail, but it's going to bark at me and tell me all the metrics. What I literally did is started trying additional ones of these. I tried KID. KID actually blew up on an error, and then PR50K3. That metric works on low GPUs. I believe it's less intense. I have not studied that particular error metric at length. If I was working with this a lot more, I probably would. It seems to be a less than 1 sort of number that slowly goes lower and lower as your images are trained more effectively. But now, if I run this whole thing, and I'm not going to change the snapshot frequency, because I don't care, 50 is fine. This actually trains relatively quickly. I like a snapshot maybe every 12 hours. It's just a preference. And let's run that. And now it's going to start up everything. So when you're in a low RAM situation like this, you want to look at all those configuration options. And the best way to get the configuration options, I mean, documentation is great. And NVIDIA has pretty good documentation in a lot of areas, but the best documentation is the documentation you can compile, namely code. So I'm going to go to train PY. There it is. And this shows me all of these options that I can set. So I can actually go in and set the batch size. And I was playing around with that a bit. The batch size, they have an auto mode for this. And NVIDIA's auto adjuster for this really does a great job. I just went back to using auto and rather than trying to fine-tune it myself. You can also set your workers down lower. That'll help you on CPU memory. So if you're trying to run this on, I don't know, like a 4 gig machine or an 8 gig, good luck. But you might want to take the workers down because then you're going to have less CPU concurrency and you're not going to potentially use as much memory. But you can see it's now back at the warning. And my fan is sounding much more robust, which is good. It looks like it's going to continue. So I'm not going to completely wait for that because that could be a good 5 minutes. But there you have it. Those are some suggestions on how to run StyleGAN2 ADA on a 8 gigabyte GPU. Less than 8 gig, I don't know, you're gonna have a hard time. You're going to really need to constrict the resolution even further and perhaps even manually take that batch size smaller. Definitely don't use the FID error metric. That seems to be considerably expensive and won't affect your overall quality. It just is a measurement to help you as it's going through. The measurement I use is just visually looking at those images as they train. So thank you for watching this video. And if you're interested in artificial intelligence and GANs, computer vision, please subscribe to my YouTube channel. And if this video was useful, please give me a like. Thank you very much.